this brings us then to Newton's first law. And Newton's first law is a law about balanced forces. Okay, so whenever you have balanced forces, Newton's first law is coming into play. So if you have an object, and I'll just draw a wee box or something in here, and it's sitting at rest, then that object has got balanced forces acting on it. So we'll only consider right or left motion for a moment. If it has balanced forces acting on it, to the right or to the left, we'll just call them F. Then there are two situations which can be going on. First, if it's at rest. So there's two parts to this law. If it is rest, it will stay at rest. However, it could be moving and still have balanced forces acting on it. So if moving, it will continue to move at a constant speed in a straight line. And that's that whole thing there. The whole thing is Newton's first law. Either the object is rest and it will stay at rest, or if moving, it will continue to move at a constant speed in a straight line. Now you, in questions, those are the words you always look out for. Constant speed. Because then you know that the forces are balanced. And they might tell you that there was a forward force of 20 newtons acting on an object. And they might say, what the object's moving at a constant speed, what is the force of friction acting on it? And you know then it also has to be 20 newtons backwards. Okay, here we have a ship. It asks you to label the forces acting on it. You have got 5 forces there, but it depends on the ship, what kind of motion the ship has, what size those forces are. But we'll just label them for now. Now, the first one is the forward force of the ship going in this direction. And normally that force is called thrust. Or it could be the engine force, or sometimes they might say motive force. You have 2 forces acting backwards. You have air resistance and friction. And they're usually combined together and they just call it drag or something like that. Now, the upwards and downwards force. Obviously, the downwards force has to be the weight of the ship. And the upward force, what's keeping that force up? And it has to be something to do with the water. And so that force, due to the water pushing up on the ship again, has got a name, and the name is upthrust. And that's a force exerted by water on an object which is floating in it or submerged in it. It's called upthrust. All right, I'm just going to I'm just going to show you what happens whenever you have a slightly different situation. A ship arrives at a port and is loaded with a cargo. What happens to the weight of the ship? Now, obviously, if you put more cargo into your ship, it's going to increase. Now, unless a boat is going to sink or go downwards, the upthrust, which is keeping it floating on the water, also has to increase. And so that's what happens. They're obviously not going to load up the ship and it sink. So the upthrust due to the water also increases. And what is the largest force, weight or upthrust? And the answer is neither. And the reason is because the boat is floating, or you could say it is not moving up or down. Now these are typical types of questions that you might get. All you have here is an object with two forces on it. This was an animation, so that's why there's an arrow beside each one. You can just ignore that. And it says, in what direction, if any, will the following objects move, or stationary objects move? So you have to look for balance forces. If there's no balance forces, then it's going to move in the direction of the bigger force. And so the direction of the bigger force in each case, there's 10 newtons up and 30 newtons down. So the bigger force is downwards, and it's going to move in the direction of the 30 newton force in that case. In this case, stationary object, upward force of 10 newtons, downward force of 10 newtons, it won't move because those are balanced forces. And I'll just write that as balanced F. The next one, you have an upward force of 45 newtons and a downward force of 30 newtons. So the bigger force there obviously is 45 newtons. And therefore that object's going to move up. And the last one, you've got an object of 30 with 30 newtons to the left and 25 to the right. So the 30 newtons is bigger, it's going to move in that direction. Now we can also calculate what the resultant force is in each case. And the resultant force is the overall force. So if you have 30 newtons down and 10 newtons acting against it, the overall force there, or resultant force, is actually 20 newtons. This one has no resultant force because the forces are balanced. In this one, the upward force is 45 newtons, the downward force is 30. So obviously overall you're going to have 15 newtons upwards. So it's 45 take away 30. I'm just going to write the direction up and this one's down. Because force is a vector, you should always write its direction as well. And the last one, you've got 30 newtons to the left and 25 newtons to the right. 30 newtons is bigger. The resultant force is 30 take away 25, which is 5 newtons. And it's going to be to the left. I'll just write an L beside that. 5 newtons to the left. Now, when forces are balanced, you'll see different diagrams and different questions. When forces are balanced, what happens to the 2 Newton meters? So if you were to do an experiment like this and you had a look and you pulled equally hard on each force, or on each balance, Newton balance here, what would happen? Well, first of all, the Newton meters would be balanced. And they would read the same value. And in terms of movement, what's going to happen there? They won't move.